Hey everyone, this is the second video in a series where I'm building a REST API using TypeScript, Postgres, and TypeORM. If you haven't seen the first video already, you can watch that, but I don't think it's completely necessary if you're only interested in some parts of this second video. So first of all, today I'm going to be trying to improve some developer productivity things in the project. For example, I'm going to be setting up developer mode, improving routing, adding a middleware, setting up app configuration, and setting up API login. So this is what we're going to be doing today. So first of all, last time we started running our Postgres database in a Docker container. So I'm just going to run that in daemon mode using -d in the background. That's going to start our Postgres database. And then I'm just going to start our application and verify that everything's working. So we can see it's running on port 3000. If I go over to Postman here and try to create a user, we can see that this works. Okay, so the first thing we want to do, as you can see, if we were to make a change anywhere here, if I was to say add just a console.log hi, every time we make a change here, we would have to stop and start our application to see the change reflected. So this isn't very good for developer productivity. We would like to add some sort of hot reloading so that we don't need to keep stopping and starting the application every time we make changes. So there's a very popular node module called nodemon, which we can use to do this. So let's set that up now. In our package.json, we're going to add another script, and we'll call this script dev. And we're creating a separate one because we might not necessarily want to use nodemon in a production environment. This is just something that we would use locally. So let's just say nodemon-w, and we want to watch all TypeScript files. And we're going to run index.ts the same as before. So in order to use nodemon, we have to install that node module. And as I said, we're not going to use this in production. It's only going to be used locally. So we should install that as a dev dependency. So let's do npm i --save dev nodemon. So that's installed now. Let's see if our dev script works. Let's do npm run dev. So it looks like it's working. We have our hi. Now if I go back to this file, add an exclamation, we can see that the application has just restarted itself automatically. So that's exactly what we want. So something actually happened there, which is interesting. It looks like it failed because the application is already running. So I'm guessing this is just some sort of an edge case that nodemon gave us. It generally doesn't happen like that. So if I again add console.log hi, save, we get that log, the app restarts. If I remove the log, save again, we can see that this is all working. The hi isn't printed the second time. So now when we're working here, when we're making changes, our server is going to hot reload itself and we won't need to keep stopping and starting that manually. So that's the first developer productivity thing we can add. So that's great. We have that done and out of the way. The next thing is improving the routing with async await. So right now, this doesn't really work so well in some cases, in particular error handling. We aren't really bubbling up errors, and it's also a little bit strange here that we're checking whether this is an instance of a promise. We should be handling all requests in the same way. So just to show you an example where this doesn't work well is if we try to post a user that doesn't have a first name, and we send that, we get this weird error socket hang up here. So we didn't get any response. And basically the application has just crashed. So we aren't handling errors very well. You can see there's a null value for first name and this isn't allowed. And if I was to restart the application and was to try to do the same thing, except this time we want to delete a user with an ID of 10, we get the same socket hang up here. We never received a response. And over here, we can see the app crashed again, basically because it couldn't remove an undefined entity. So we want to improve this routing a little bit so that we're able to handle errors and these kind of edge cases a little bit better. So let's see. So first of all, we want to make this part asynchronous. And this is going to allow us to use async await here instead of this promise syntax. So let's make this async first of all. And then in the result, because the result is going to return a promise, we can basically always use await here to get the result. And then we just basically want to do res.json result. Like that. So this is handling the positive case very well. But what about the case when we have an error? So in order to do that, we're going to wrap this in a try. And a catch. We're going to catch any exceptions here. And we're going to use next with the error. And what this is basically doing in Express, we can pass this error onto the next middleware. And in Express, by default, there is a middleware there, which is going to handle errors and return status 500 to the user. So what we've done here should work pretty well. We are using async await, and we're going to catch any errors and return those errors to the user. So let's try again. We're going to delete a user with an ID of 10. We can see we get back this kind of HTML. We're getting back 500, and we're basically bubbling up the entire error here to the user, which is definitely better than we were doing before. The application isn't crashing. It's still there. We're logging the error, but we aren't. The application isn't crashing. And that's because of this try catch that we have. So let's try to do the post. A user without first name. We can see this, so that's good. Let's give them a first name just to make sure that the positive case is still working. So we can see here this is still working. We're getting back 200, okay. So this is basically Next's default error handling middleware that's sending back this HTML. And that's fine for default behavior, but we could do something a little bit better than this, I think. So we're going to create our own middleware to actually handle these errors. And to do that, we're going to say app.use, and we're going to pass in handle error. And this is going to be a middleware function which we can create ourselves, and it's going to handle all errors. Right now it's undefined, so we need to create that function. So let's say function handle error. Because we're using this function as middleware, we're going to get a couple of parameters passed in by default. So we're going to have an error passed in. We're going to have the request passed in. We're going to have the response, and we're going to have the next function in the middleware. Because the purpose of this function is to handle errors, we want to return those errors to the user in a nicer way than this big HTML. So we're going to say res.status, and we're going to check if the error has a status code, because in the future we might want to attach status codes to errors so we can bubble those up. And if the error doesn't have a status code, then we're just going to return 500. And we're going to just send, and we can send error.message. And this is just going to bubble up the error message. So now the error below here should have went away, and that's fine. So let's save, and let's see if this acts any nicer. So positive case, we can create a user, that's fine. If we create a user without a first name, we can see we actually get this nice text error now, saying null value in column first name of relation user violates non-null constraint. We could actually change this a little bit. We could send JSON instead, and we could say message, and this is just going to send it as JSON instead. So let's go back. Let's hit send. So now we can see that we have this status 500 and we're returning the error message like this. Let's try the same thing for delete. We can delete a user with an ID of 100 and we can see cannot remove, given value must be an entity. Instead, undefined is given. So this is kind of a weird error to give your user. So it doesn't really, it's difficult to understand. So we could improve this a little bit. So just to show you how we can kind of generate our own errors and send those, we could go in here to the controller, into the user controller, and here where we're removing, you can see we're assigning user to remove here, and then we're going to remove it. So let's change this to a const first. So we can check at this point if user to remove is defined or if they're present. And if they aren't, we can generate an error before we even get to the repository layer and try to delete them. So we can say if no user to remove, we just want to throw an error and say user does not exist. If we save that, so just to show here, we're throwing the error here. In our routing here, inside this try catch, it's going to try to do this, but an error is going to be thrown. It's going to catch the error, and the error is going to be passed into this middleware, handle error, and this part here is going to be ran. So that should be saved now. Over here, remember we had this message that wasn't very user-friendly before. If I try to run this again, we can see that we get an error with a message, user does not exist. So we've set up developer mode using nodemon, we've improved the routing with async await, we've added a middleware to handle errors. Next we want to set up an app configuration. So first of all, what is an app configuration? So our app can be configured in a couple of different ways. It's not very complicated right now, so there's not so many different ways to configure the app. One thing I can see here straight away is the port that we're running the app on. So this is something that we don't really want to have hard coded in our code. It would be much nicer if this value was configurable so that we could configure this in different ways. When we're in production, we might want to use a different port. We want to use 80 or 443 for HTTPS and different things like that. Also, if you're running on Heroku, they inject a variable called port, and you need to mount your application on that port. So, and this port is completely dynamic. Each time you deploy your app, it could change. So you want to read this from the environment variable. So obviously you could do something here. You could just say process.env.port or 3000. And this would work completely fine. But it would be nicer if we had a centralized place in our application where all the configuration happens. So in this place, we might configure everything that can be configured in our app. We have this one central file, and then every other part of our application can read from that file. So let's try to do that. So first of all, we're going to create a file. We're going to call it config.ts. We should be putting this inside the source directory. And here we're just going to do export const port equals 3000 equals process.env.port, and if that's not defined, we're going to default to 3000. So that's nice. If we save that, it's hot reloaded. We're going to go back here and we're going to import this config. So here we're going to say import port from config. So then we're able to use this port anywhere throughout our application. And we're going to just pass in port here now instead. And as well, we're just going to change this log line. Let's do it like this. We don't need this last part. And instead of 3000 being hard coded here, we're going to just pass in port as well. So now if we save, we can see we're getting this log. Started on port 3000. If I change this to 3001, we can see that it's hot reloaded and it's restarted on 3001. Nice. And just to show you that this is, this would use the port environment variable as well. We could do something like export port equals 3002. And then we want to npm run dev. And still started in port 3000. Let's see if I can make that. So it looks like it was just something to do with the spaces of the export, which wasn't allowing it to work. So now if we set this to 3003, restart our application, it started on 3003 now. Nice. So let's just unset port for a second. And it should start on 3000 again. Nice. So as a developer, it's quite difficult to maintain all of these environment variables if you're using them on your machine. So there is a way to manage this, and there's a handy npm module here called .env, which you can use to do this. And we're going to use this. It basically allows us to store all of our environment variables in a .env file in our application. So let's just copy this. And we're going to paste that to the top of our config file. You want to use this quite early on in your application, because this is going to load the .env file and the config. If we were to put this after this, then it wouldn't have read the .env file before this point, so it wouldn't be able to read the port from that file. So if I save, it's going to fail because we don't have .env yet. So let's just do npm I -- save dev. We want to save the .env npm module. Nice. And we're going to create a new file in the root of our project here. So it isn't going to be inside source, and we're going to call it .env. So here we can do something like port equals 3100. And if we save and start our application, now we can see it started on port 3100. Something interesting here, if I was to change this back to 3002, our application isn't going to hot reload. And that's because right now, the module we used to do the hot reloading, we said we want to watch all TypeScript files. We actually want to watch now as well the .env file. So we can just add this -w.env. If we save that, reboot our application from the start, we can see it started on 3002. If we make a change here to run this on 5006, 5005, it will restart like that. Nice. So we have this kind of centralized app configuration, and we also have hot reloading working whenever we change this .env file. Just to note, in general, I wouldn't commit this .env file to source control, so I would add it to the git ignore, because you might keep secrets here like authentication tokens and things like that, and you obviously don't want to push them up to git or your source control. So generally, this is a file that you would keep yourself locally, and you would add it to the git ignore so it isn't pushed up to git. Nice. So now that we've set up the app configuration, the last thing I wanted to do today is set up some sort of API login. So right now, whenever we are sending API requests, like getting all the users, we can get the users. Our API doesn't log any of that. So we just have this one log line, and if we ever have any errors, we're going to log those as well. But it would be nice in our application to be able to see logs of all the requests that are happening and other information. This can be useful when you're in production for monitoring, and also just for keeping an eye on your application, metrics and things like that. So we're going to set up some pretty simple API logging. there's a nice middleware called Morgan, which you can use to do this. There's a couple of different choices here. Some people use Winston, but in general, I like to use Morgan as my API login. And the reason for that is that they provide, this can be used as a nice middleware, and I just find it very easy to set up. Here you can see it being used. So let's set that up. We're going to stop our app. We're going to do npm i --save Morgan. And in our index.ts file, we're going to import star as Morgan from Morgan, like that. And generally, Morgan is used very early on in the middleware cycle. So you can see we're adding different middlewares here, like our error handler. Generally, Morgan would be the first one that we want to add, because if we added Morgan after the error handler middleware, we would never log out requests that ended with an error, because we're going to send this response back and it would never get as far as the Morgan middleware. So we're just going to do app.use Morgan, and there's different configurations you can pass in. I'm just going to show you a couple of those. So tiny is one that I generally like. So if we do npm run dev again, and we can see it started on port 3000. Now if we do a get on users, we can see that we have this log line, get users 200. So 200 is the response code. I'm actually not sure what this is, and this is the amount of time it took for the response. So if I was to do like a post on users, we're not sending a first name, so this is going to result in an error. And let's send a first name. Hit send 200 and 288 bytes. Maybe the bytes is what that was, 53. Okay, I'm actually not sure. So that's the response code 500. We can see post, and all of that. So let's take a look and see if we can figure out what this first number is from their docs. So we're using tiny. So this is just a predefined format string. It could be the content length. And as you can see here, you can do, you can create your own formatting for these logs, but they give you a couple of different nice ones. So let's try combined and see how it differs. So restart, send this. So combined here, you can see it's much longer, and this is probably more verbose, which would be useful for a production environment. But in general, for development, I like tiny. I think it's nice and short, not too verbose, but it describes exactly what's going on. Okay, so we've went over quite a lot today. Just to summarize, I wanted to focus this video on making some improvements to developer productivity, as well as fixing some bugs. So we set up developer mode with hot reloading using nodemon. We improved the routing and fixed some bugs by using error handlers. We set up app configuration and used .env to read the configuration from a file. And we set up some API login using Morgan. So thanks for watching. I'm probably going to make another couple of videos on this same topic, bringing this TypeScript REST API to the next level. So if there's anything you'd like to see in particular, let me know in the comments. Thanks for watching, and I'll see you next time.